In this session, we will discuss about electrochemistry, its definition, classification of electrochemical cells and their differences, the construction and working of Daniell cell, and EMF of a cell. Electrochemistry is defined as a study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. An electrochemical cell is a device capable of either generating electrical energy from the chemical reactions or using the electrical energy to bring about chemical reactions. Now we will discuss about classification of electrochemical cells. The electrochemical cells are classified into two: voltaic or galvanic cells and electrolytic cells. In voltaic cells, the chemical energy of a spontaneous redox reaction is converted into electrical energy. They are also called galvanic cells. The voltaic cells play a key role in our day-to-day life. For example, powering our mobile phones, radios, TV remotes, etc. On the other hand, in electrolytic cells, the electrical energy is required to carry out a non-spontaneous chemical reaction. For example, when you are charging your cell phone, you are actually running an electrolytic cell, that is, converting the electrical energy into chemical energy. Next, we will discuss the differences between galvanic cells and electrolytic cells. The galvanic cell changes the chemical energy into electrical energy, whereas the electrolytic cell changes the electrical energy into chemical energy. In galvanic cells, the anode is negative and cathode is positive, whereas in electrolytic cells, the anode is positive and cathode is negative. In galvanic cells, spontaneous reaction occurs. On the other hand, in electrolytic cells, non-spontaneous reactions occurs. Galvanic cells does not require external voltage source, whereas electrolytic cell requires external voltage source. Next, we will discuss the construction and working of Daniell cell. This is the basic setup of a Daniell cell. It consists of two containers. One is filled with copper sulfate solution and the other is filled with zinc sulfate solution. A zinc rod is dipped in zinc sulfate solution and a copper rod is dipped in copper sulfate solution. The two electrodes are connected with the help of a wire. Also, a switch and a voltmeter is connected in series. The two solutions are interconnected with the help of a salt bridge, which helps to maintain electrical neutrality between the solutions. As soon as the switch is closed in the circuit, the current starts to flow from copper electrode to zinc electrode. This can be confirmed by the deflection of needle in the voltmeter, which is connected in the series. Now we will discuss the reactions taking place at two electrodes. The zinc undergoes oxidation and acts as anode to form Zn2+ and 2 electrons. These two electrons are then transferred through the wire to the copper electrode and then finally into the copper sulfate solution. The Cu2+ ions in the copper sulfate solution accept these two electrons and reduce to form copper, and this copper is deposited over the copper electrode. The overall reaction taking place in a Daniell cell is shown here. We will now discuss the working of Daniell cell in detail. The electrolytes are in the ionic form, that is, the zinc sulfate dissociate to form Zn2+ and sulfate anion, whereas copper sulfate dissociate to form Cu2+ and sulfate anion. The zinc undergoes oxidation and form Zn2+ and 2 electrons. The Zn2+ ion becomes part of the zinc sulfate solution and the 2 electrons are transferred through the wire into the copper sulfate solution. The Cu2+ ions in the solution accept these 2 electrons and get reduced to form copper, and this copper is deposited on the copper electrode. The electrode at which oxidation takes place is called anode, and the electrode at which reduction takes place is called cathode. The electrons flow from anode to cathode, and the salt bridge is filled with sodium sulfate solution, which helps in the transport of sulfate ions across the two solutions. Next, we will discuss about electrode potentials, that is, oxidation potential and reduction potential. The potential difference that causes the flow of electrons between an electrode and its ions in the solution in which the electrode is dipped is known as electrode potential. It may be reduction potential due to the reduction reaction at the cathode or oxidation potential due to the oxidation reaction at the anode. Oxidation potential is the ability of an electrode to give up electrons and become oxidized, whereas reduction potential is the ability of an ion in the solution to accept the electrons from the electrode and become reduced. Next, we will discuss the electrode potentials of some important elements. The electrode potentials of these elements have already been determined, and the values are given as follows. The electrode potential of scandium is minus 2.10, titanium minus 1.60, iron minus 0.44, nickel minus 0.24, copper plus 0.34, etc. Next, we will discuss about EMF or electromotive force of a cell. The cell potential or EMF of a cell is defined as the difference between the electrode potentials of the cathode and the anode. That is, cell potential or E cell equal to electrode potential of cathode minus electrode potential of anode. In simple words, electrode potential at right minus electrode potential at left. The right side deals with the reduction of copper and the left side deals with oxidation of zinc. The electrode potential values of copper and zinc are already determined. The electrode potential of copper is plus 0.34 and the electrode potential of zinc is minus 0.76. Substituting the values in the equation, we will get the answer as 1.10 volt. So the EMF of Daniel's cell is 1.10 volt.